Welcome, everyone. Whether you're an engineering student just starting out, a seasoned technician, a PLC programmer, or, a professional working deep in the trenches of industrial automation, I am absolutely thrilled to have you here for this explainer. Today, we're unpacking a piece of tech that is quietly but massively transforming the way modern factories and industries operate. We're talking about VFDs, variable frequency drives. And by the end of this explainer, you're going to see exactly why these devices are literally the beating heart of energy efficiency and motor control in the industrial world. Let's get into it.
So here's our quick roadmap for today. First, what is a VFD? Second, how a VFD works. Third, real-world applications. Fourth, benefits and mistakes. Fifth, future trends. And finally, an introduction to Devi automation solutions.
Okay, Section 1. What is a VFD? An introduction to variable frequency drives. Let's start with the foundational problem here. For decades, traditional motor control was just incredibly inefficient. It was essentially just a simple switch. A motor was either completely off or it was screaming along at 100% full speed. And that caused a massive waste of electricity, not to mention heavy mechanical stress on the equipment. Well, enter the VFD. A variable frequency drive is an electronic device that controls the speed and torque of an AC motor by precisely varying the input voltage and frequency. Think about a standard motor switch like a car that only has two speeds, 0 and 100 miles per hour. That'd be a complete nightmare to drive, right? A VFD acts exactly like the accelerator paddle in your car. It gives the motor the exact amount of power it needs exactly when it needs it. It really is the ultimate solution for energy efficiency in any factory setting.
Moving right along to Section 2, how a VFD works, the internal mechanics. So we know what it does, but how does it actually pull this off? Let's do a quick anatomical breakdown of how power flows through this incredible drive. It's basically a four-part journey. First, your standard fixed AC input enters the system directly from your power grid. Step 2, it hits the rectifier, and this converts that AC power into DC power. Step 3, that power moves into the DC bus, which acts kind of like a reservoir. It filters out the noise, stores the DC power, and really smooths it out. And finally, Step 4, this is where the magic happens, the inverter. It takes that smooth DC power and converts it back into a highly customized variable AC power. And it's this custom AC output that dictates the exact speed and torque of your motor. Now, to make that whole four-step journey possible, we rely on some microscopic heavy lifters inside the unit. First up is the IGBT, or the Insulated Gate Bipolar Transistor. This component lives right in the inverter section, and it's responsible for insanely high-speed switching. It turns the DC power on and off thousands of times a second. I mean, literally faster than a hummingbird's heartbeat, just to create that custom AC wave. The second crucial component is the DC bus capacitor. This sits right in the middle of the drive, absorbing fluctuations and smoothing out any voltage ripples, so the inverter gets a perfectly clean power supply.
But, those power components can't just operate in a vacuum. They need an essential support system. So you've got the control board, which is basically the brain of the VFD, processing all the logic and sending signals down to the IGBTs. Then you have the cooling fan. All that high-speed electrical switching generates a ton of heat, so temperature management is absolutely vital. And finally, the display and keypad. This is the human-machine interface that actually allows technicians and engineers to program parameters, monitor performance, and troubleshoot faults right there on the factory floor.
All right, Section 3. Real-world applications. Where is it used?
Now that we've zoomed in on the internal components, let's zoom out a bit. Where do these VFDs actually live out in the real world? Well, the short answer is pretty much everywhere there's an electric motor. But we can break this massive list of applications down into three logical categories, so it's a bit easier to digest. First, pumps and HVAC systems. This includes bore well pumps, cooling towers, chillers, anywhere controlling fluid and airflow is critical. Next, we see manufacturing applications. Think of your conveyor belts, CNC machines, packaging lines, extruders, where having precise speed control directly dictates the quality of the product. And finally, heavy industry. Cement plants, steel manufacturing, sugar mills, they all rely on massive VFDs to handle incredibly heavy loads without just ripping their mechanical gears to shreds during startup.
To really ground this theory in reality, just picture these everyday examples. When you drive past a sprawling agricultural field, VFDs are running the irrigation pumps, adjusting water pressure based on actual demand. Inside a bustling Amazon warehouse, VFDs are the reason those factory conveyor belts speed up or slow down so smoothly without, throwing packages everywhere. And hey, if you're sitting in a tall building right now,
A VFD is highly likely controlling the building's water pump, ensuring the water pressure on the 50th floor is exactly the same as it is on the ground floor. It's pretty amazing when you think about it.
Let's look at Section 4, Benefits and Common Mistakes, Best Practices.
So implementing this technology sounds great, but what's the actual operational impact? Well, it's really all about balancing incredible benefits against potential nightmares. On the positive side, you get massive electricity savings, the ability to softly start and stop motors, which totally prevents mechanical shock and a dramatically longer equipment lifespan. But, and this is a big but, these benefits can be completely wiped out by some really common mistakes. I mean, have you ever seen a drive violently fail because of a cooling fan failure due to poor ventilation? Or maybe a motor burn out because of missing earthing or totally wrong parameter settings? These are simple cable errors and overloading mistakes that can literally cost a factory thousands of dollars in sudden downtime.
To prevent those nightmares, you absolutely must follow some critical installation steps. And to all the PLC programmers and engineers tuning in right now, proper motor selection is non-negotiable. You have got to ensure you have the correct cable sizing to handle the current. Solid earthing, absolutely mandatory for safety and to prevent electrical noise. You also need proper MCB and MCCB protection to guard against short circuits. And finally, please don't forget your input and output reactors along with harmonic filters to keep your power grid clean and your drive functioning perfectly.
Which brings us to Section 5, Future Trends in VFDs, the next generation.
So we've mastered the present-day best practices. Now let's explore where VFD technology is heading next. Because let me tell you, the drives of tomorrow are doing a whole lot more than just spinning motors. We are entering the era of Industry 4.0. This new generation of VFDs, they're essentially incredibly smart computers. Through the Industrial Internet of Things, or IIoT, drives are constantly talking to each other and to the cloud, creating true smart factories and smart agriculture setups. But the real game changer here is AI-based motor control and predictive maintenance. Instead of just waiting for a machine to break down, the AI inside the VFD analyzes these microscopic changes in electrical current to tell you, sometimes weeks in advance, that a motor bearing is about to fail. It is completely revolutionizing traditional maintenance.
Let's hit Section 6, Devi Automation Solutions, your automation partner.
Bridging the gap between this cutting-edge future technology and your practical day-to-day automation needs requires a trusted partner. You really need a team that understands everything from the basic wiring all the way up to the advanced AI algorithms we just discussed. And that brings us to Devi Automation Solutions. Their mission is completely focused on providing smart technology, powerful solutions, and building a better tomorrow. They are the premier resource for implementing everything we've unpacked in this explainer, acting as your dedicated go-to automation partner.
Devi Automation Solutions offers incredibly comprehensive suite of services. Whether you need overarching industrial automation, detailed PLC programming, HMI and SCADA integration, VFD installation, or maybe you're ready to upgrade to AI and IIoT systems, they have the expertise. They even expand into smart agriculture, home automation, and solar solutions. I highly recommend subscribing to the Devi Automation Solutions channel for more expert content on all of these topics. And for any business inquiries or project consultations, you can reach out to them directly at deviautomationsolutions@gmail.com.
I want to leave all you professionals and students with this final thought to ponder as you look at your own industrial setups or your future careers. VFDs have evolved from simple motor controllers to the intelligent brains of the modern factory. The technology is here, it's efficient, and it is incredibly powerful. So, the only question left is your facility ready for the AI-driven automation revolution? Thank you so much for joining me for this explainer, and keep innovating.